So for this exercise we want to write each of the quadratic formulas in turning point form, find the roots and graph. So this is the equation in turning point form. So every quadratic can be expressed in this form, and the value of b is your x value for the turning point and c is your y value. So this is what it looks like graphed. So to do this we use the completing the square method. So we've done this before. Have a look at my other videos if you're not sure. So x squared, it's already only got a coefficient of 1 in front, so we don't need to do anything there. And then minus 10x. Now we want to halve the 10, the b value, and then square it. And we add that, so that's 5 squared. And then we want to also subtract that again, because that doesn't really belong in this equation. And then we add the 21. So now this here is actually the formula for the perfect square of x minus 5 all squared. And then we carry these two values along, so it's minus 25 plus 21, so it's x minus 5 squared minus 4. So b is 5 and c is negative 4. So the turning point is 5, negative 4. Now let's go ahead and find the roots. So equating that to 0, we have x minus 5 squared minus 4 equals 0. So bring this over to add. We have x minus 5 squared equals 4. And then taking the square root of both, x minus 5 equals the square root of 4 equals plus or minus 2. So x equals 5 plus 2 equals 7, or x equals 5 minus 2 equals 3. So 7 and 3, they are your roots or your x-intercepts. Now let's find the y-intercept. At x equals 0, y equals 21. So we go ahead and graph that. So 7 and 3 are our x-intercepts. 5, negative 4 is our turning point, and y equals 21 is our y-intercept. Now we can go ahead and draw in our quadratic diagram. And x equals 5 is our axis of symmetry, which is through our turning point. Okay, part B, we've got x squared minus 9x. Now let's add 9 on 2, and it's got to be squared. Got to now subtract 9 on 2 squared, plus 20. So this can be shown as a perfect square, so x minus 9 on 2 all squared, minus 81 on 4, I've just squared this, the top and bottom, plus 80 on 4, and that gives x minus 9 on 2 squared, minus 1 on 4. So that's in the turning point form, where the turning point is 9 on 2, negative a quarter. So let's go ahead and solve this equation to find the roots. So we've got x minus 9 on 2 is equal to the square root of 1 on 4, which equals a half, and that's a plus or minus. So x is equal to 9 on 2 plus a half, which equals 10 on 2, which equals 5, or x equals 9 on 2 minus a half, equals 8 on 2 equals 4. Also, let's find the y-intercept. At x equals 0, y equals, looking at this one here, 20. And lastly, let's look at the coefficient in front of the x squared, which is a. It's a positive 1, which means the shape is going to be like that, not like that. Okay, let's graph it now. So this is 4.5 in the x and -1/4 in the y. So that is this point here. Then we've got the x-intercepts are 5 and 4. So that's there and there. And the y-intercept is at 20, which is there. Obviously it's not to scale, and so we have this sort of thing going on. So this is the axis of symmetry at x equals 9/2, which is 4.5. Okay, let's go ahead and do part C. So we've got x squared plus 2x. Now 2 divided by 2 squared is 1 squared. And we've got to subtract 1 squared, and then we've still got -24 there. So as a perfect square, we've got x plus 1 squared minus 25. So the turning point for this equation is -1 and -25. Now let's solve it to find the roots. So from equation 1, we've got x plus 1 squared minus 25 equals 0 for the roots. Bring this over and square it both sides. We've got x plus 1 is equal to the square root of 25 equals plus or minus 5. So x equals 5 minus 1 equals 4, or x equals -5 minus 1 equals -6. Now let's find the y-intercept. So y-intercept at x equals 0, y equals -24. So that's this value here. And let's look at the coefficient of a is a positive 1. So we know it's this shape, not this shape. Okay, our turning point is at -25 and -1. And then we've got 1, 2, 3, 4, -1, -2, -3, -4, -5, -6. So these are our x-intercepts. And then we've got y equals -24 y-intercept. So we go ahead and draw that, and it's going to be symmetrical about our turning point, and that's what it looks like.